Hello and welcome back to the video. Going ahead with our topic on motion. Okay, so today we are going to talk more upon force and motion. All right, so we are going to deal with the concept on force, what are the different types of forces, and also we are going to talk about the three laws of important laws of motion. Okay, these three important laws of motion are also known as Newton's law of motion. Okay, basically it was formulated by the scientist known as Sir Isaac Newton. So let us get into the video, and then let us understand what is a force, and then what are the different types of forces. All right. Okay. So the first thing we need to understand is what is force. All right. So now let us see the definition of force. A force is an effort that changes the state of an object at rest or at motion. It can change an object's direction and velocity. Force can also change the shape of an object. Okay. So now, what does this definition mean? Is that it means that a force is a kind of an effort. Okay, you put an effort to do something, right? So this is in a force is a kind of an effort. Okay, which changes the state of an object which is at rest or which could also be in motion. Okay, so एउटा कुनै पनि एउटा रेस्टमा भइरहेको या त कुनै पनि एउटा मोसनमा भइरहेको अब्जेक्टलाई चाहिँ when you try to apply some force, what happens? It changes its state of rest or its change of or its state of motion. Okay, or what could also happen is a force, whenever its force is applied, it can change an object's direction and also its velocity. Another thing could be whenever a force is being applied to some kind of an object, it can also change its shape. Okay, example say about to give an example, what we could do is suppose if we need to see that forces can change the shape of an object. Okay, now how does this happen? You imagine yourself holding a kind of that what do you call it, this smiley ball you get, right? It is a very squishy ball, है ना, एकदम नरम खालके स्पन्ज भएको बल हुन्छ. So what happens? It is round at first. It is a spherical ball at first. And what happens when you try to press it? It starts squeezing. It loses its shape. Okay. So what is happening? You're applying some force when you're pressing it. So when you're applying some force, what is happening? The ball from its what do you call it? From its round shape, it's being squeezed into some other irregular shape. So what is happening whenever you're applying some force? There is a change in the shape of an object. All right. And next thing, if we need to say that force is something which changes an object's direction or velocity, what will happen is suppose you think, mm, okay, so change in velocity could also be increasing the velocity or decreasing the velocity, right? So you think of yourself riding a bicycle, or think of yourself riding a bike or a car, anything. Okay, so you're riding or you're driving a car. So what happens whenever you see something in front of you? You try to apply the brakes, you know, and whenever you're trying to apply the brakes, what will happen? You're applying some kind of force to it. Okay, you're applying some force, and due to that, the brake the application of brake happens, and then the car stops. Okay, so basically when you see that, whenever you are suppose riding a cycle, all right, and then you see something and then you press your brakes, what will happen? You are going with a constant speed, होइन, एउटा कुनै पनि एउटा तिमीहरू एउटा स्पिडमा जाँदै गरेको छ अरे, स्पिडमा साइकल कुदाउँदै गरेर जाँदै गर्दाखेरि चाहिँ you apply the brakes, and what will happen? The speed of the cycle decreases slowly. Okay, so that is the change in the velocity. Okay, so these are all the these are all that you need to know about force. Okay, and basically speaking, okay, on the top of the classification, forces can be divided into two types. They are contact and non-contact forces. All right, so for the two types of forces are contact forces and non-contact forces. Sorry. Now let us see what are contact forces and non-contact forces. So the contact forces, okay, the forces which act on bodies when they are in physical contact are called contact forces, and non-contact forces, the forces experienced by bodies even without being physically touched, are called as non-contact forces or forces at a distance. Okay, so you can tell that from the name itself. I know contact and non-contact force. So obviously, contact forces, in case of contact forces, it will be applied to two objects. Okay, whenever they are in contact with each other, and non-contact forces happen whenever the two objects are not in contact with each other. Okay, and now coming back to contact forces, the types of contact forces are frictional force, normal reaction force, tension force as applied through the strings, okay, and force exerted by a spring, okay, spring force पनि हुन्छ, त्यहाँको force exerted during collision. Okay, so all these kind of forces are the contact forces. Now coming back to non-contact forces, types of non-contact forces are magnetic force, electrostatic force, and gravitational force. Okay, so all these non-contact forces, the magnetic, electrostatic, and gravitational force, all these kind of forces will be studying in the higher classes. All right. So in class 11th and 12th, there is a separate chapter dedicated to full electrostatic forces and magnetic forces, and then even gravitational forces. All right. But right now, what we are going to study is we are going to study about the frictional forces, normal reaction, tension, and such kind of forces. Okay, so basically we are going to study about the contact forces. All right, so these are pretty much what you need to understand about forces. Now let us move on to the uh, laws of motion. All right, now let us go to the Newton's first law. So Newton's first law of motion, it implies that things cannot start, stop, or change its direction all by themselves. Okay, so what you need to understand is these are all the kind of an assumptions, or uh, all the things that you need to understand to know what is Newton's first law of motion. Okay, so what happens is it implies that the things, the first law implies that the things cannot start. Okay, it cannot start, it cannot stop, or change direction all by themselves. Okay, there has to be some kind of force which is involved. Okay, next thing is it requires some external force to cause such a change. Okay, same thing. पहिला चाहिँ के अरे एउटा कुनै पनि चिजलाई it cannot start on its own, it cannot stop on its own, or it cannot even change its direction on its own. All right, so there has to be some kind of an external force to cause such kind of change. हैन, कुनै पनि एउटा एक्सटर्नल फोर्स हुनु पर्यो जुन चाहिँले चाहिँ यस्तो खालके स्टार्ट स्टप चेन्ज डिरेक्सनहरू गर्ने खाले चेन्जहरू लिएर आउँछ. Okay, so this property of massive bodies to resist changes in their state of motion is called as inertia. Okay, so अब चाहिँ के भन्दैछ भने चाहिँ whenever a body is there, okay, and we are talking about massive bodies भनेको, we are not talking about very small bodies. Massive bodies means a bigger body which you can like feel and see and then touch and everything. Okay, like some chair, a ball, a table, anything like that. Okay, so the property of massive bodies to resist some changes in their state of motion, okay, is called as inertia. So inertia भनेको चाहिँ के हो भन्दाखेरि चाहिँ the resistance of a body, okay, the body whenever it resists to some change in the state of motion. sorry about that. And okay, so the property of massive bodies to resist the changes in their state of motion is called as inertia. Okay, a table is there, okay, it's on the ground, and table then राखिराख्छ, it doesn't move anywhere, right, until and unless some external force is applied to it, it doesn't move anywhere. तिमीले टेबललाई तानेनौ भने पनि ठेलेनौ भने एउटा ठाउँमा राखिराख्छ भने it just stays there. Okay, so that is inertia of the table. Okay, so Newton's first law of motion is also known as law of inertia because of that. Okay, so now what is the actual statement of the Newton's first law is, the first law states that the body at rest or uniform motion will continue to do so until and unless an external force acts on it. Okay, so what does it mean is a body, okay, it remains a body in its state of rest, or it could be in its state of uniform motion. Okay, it will continue to do so त्यतिकै भइरहन्छ until and unless some external force is applied to it, which means that suppose if your phone is on the table, होइन तिमीहरूको फोन टेबलमा छ अरे, त्यो त्यतिकै त्यहाँ राखिराख्छ भने it will just stay there. Alright, until and unless you pick it up, or you pick it up and then put it somewhere, or if you just push it away, so all this kind of things are the external forces that is being applied. And talking about uniform motion, again, you're kicking a ball and then somebody on the other end catches it. Okay, so the force of the ball and the motion of the ball is being stopped by somebody. There is a striker at the center of the field. त्यहाँबाट बललाई टक्क किक हिर्काएर हो, हिर्काएपछि चाहिँ it goes on to the goal post and then the ball is in motion. त्यो बल चाहिँ एउटा मोसनमा छ, त्यो जाँदैछ, किपरले टक्क गोले पक्रियो अरे होइन, the keeper catches the ball, what will happen? He is stopping the motion of the ball. Okay, so there is some kind of force being applied by the keeper to catch the ball. So it's like that. So a body continues to be in its state of rest or in state of motion until and unless some external forces applied to it. Okay, so first law, okay, depends on two conditions. And what are those two conditions? Object at rest and object at motion. Okay, so in object at rest, when an object is at rest, velocity v equals to 0 and acceleration a will also be equal to 0. Okay, so therefore the body continues to be at rest. Okay, and object in motion चाहिँ कसरी हुन्छ भने चाहिँ when an object is in motion, the velocity is not equal to 0. Okay, because the body is moving, so therefore there is a change in speed. Okay, change in speed भन्नुको मतलब there is a change in velocity. Okay, so an object is in motion. Okay, velocity is not equal to 0, that is v not equal to 0, while acceleration is equal to 0. So therefore the object will continue to be in its motion with constant velocity and in the same direction, because velocity is a vector quantity. We are talking also about the direction. All right, so that is all that you need to know about Newton's first law of motion. The statement of the law again, okay, it says that the first law states that the body at rest or at uniform motion will continue to do so until and unless some external force acts on it. Okay, now let us move on to Newton's second law of motion. So Newton's second law of motion, the second law describes what happens to a body when acted upon by an external force. Okay, now first we learned that a body which is at rest or at uniform motion, the body lies until and unless some external force is applied, it does not change its state. Okay, now you have already applied the external force. Okay, now in the second law what we need to understand is what happens. Okay, what happens when a body is acted upon by an एक्सटर्नल फोर्स. एउटा बडी चाहिँ जुन चाहिँ रेस्टमा थियो या त युनिफर्म मोसनमा थियो, त्यसलाई एक्सटर्नल फोर्सले एक्ट गर्दाखेरि चाहिँ के हुन्छ भनेर चाहिँ अब सेकेन्ड लले डिस्क्राइब गर्छ. ओके, सो इट स्टेट्स that the force acting on a body is equal to the product of its mass and acceleration. So that will be actually the statement of the Newton's law. Okay, so what is the actual statement of the Newton's second law is, the second law states that the force acting on a body is directly proportional to the rate of change of momentum. Okay, so we have already talked about distance, displacement, speed, velocity, acceleration, and things like that. Now the next important topic which comes is momentum. Okay, you need to understand what is momentum. Momentum, it is defined by the letter p. Okay, p so momentum la define garcha, and momentum is equal to m times v. Okay, it is also known as, momentum can also be written as, it is the product of mass and velocity. Okay, so that is all that you need to understand. And what does the second law say is that whenever a body is acted upon by an external force, the force which is acting upon a body, it is it is directly proportional to the rate of change of momentum, which means that the force acting on a body will be equal to some constant time the rate of change of momentum. All right, So mathematically we can express the second law as follows. Okay, so the force which is acting on a body is directly proportional. It's a proportionality symbol, you know, so it is directly proportional to the rate of change of momentum. Rate of change like the first like dp by dt. So it is the momentum is changing with respect to time. All right, so force is directly proportional to the rate of change of momentum, and the rate of change of momentum means there is a change of momentum, which means final momentum minus the initial momentum. Okay, because v is the final velocity and u is the initial velocity, and momentum means mass into velocity, you know. So therefore this is the initial momentum, this is the final momentum. So हामीले यहाँ change in momentum भनेको चाहिँ final momentum minus the initial momentum divided by t, and since we are taking the same object, so mass will be constant, you know. So f directly proportional to mass constant v minus u by t, and we know that v minus u by t is actually a, acceleration, you know. Final velocity minus the initial velocity divided by time is equal to acceleration. So therefore we can say that f is directly proportional to m times a. And now whenever we remove the proportionality symbol, you know, whenever we remove some proportionality symbol, what will happen? There is a proportionality constant which comes into picture. ल जहिले पनि proportionality symbol हटाउँदाखेरि चाहिँ एउटा कुनै पनि एउटा constant आउँछ. त्यसरी नै f is equals to kma लेख्दाखेरि चाहिँ यो k चाहिँ एउटा proportionality constant हो. Okay, here k is the constant of proportionality. All right, so त्यही पनि भन्दैछ यहाँनिर. It is equal to 1. The value of k is equal to 1 if the values are taken in SI unit. Okay, so force को, mass को, acceleration को सबको value हामीले SI unit मा लिँदैछ भने चाहिँ यो k को value चाहिँ 1 मात्रै हुन्छ. Hence the final expression will be, if we are taking it in the SI unit, okay, the final expression for the mass would be for the force would be force equals to mass times acceleration. Okay, so this is actually the second law of motion. This is actually the second law of motion. All right, so what does Newton's second law state? Again, the second law states that the force acting on a body is directly proportional to the rate of change of momentum. Okay, so and then this is the numerical mathematical expression. Okay, right, try to understand this very carefully because this is very important. Okay, now let us move on to the third law. So talking about Newton's third law, the third law describes what happens to a body when it exerts a force on another body. Okay, so in the first law we described how or what happens uh, to a body until and unless it's applied by an external force. Okay, so there is the inertia takes place. Now in the second law we understood that what happens to a body when some external force is applied to it. Now in the third law we are talking about what happens when one body exerts a force on another body. Okay, एउटा बडीले चाहिँ अर्को बडीमा फोर्स एक्सर्ट चाहिँ कसरी गर्छ भनेर चाहिँ अब हामीलाई न्युटन्स थर्ड लबाट पर्छ. Okay, so the third law states that for every action there is an equal and opposite reaction. Okay, so basically what we are going to do is we are going to talk about action reaction pairs in our third law of motion. Okay, the statement is very simple and तिमीले पहिलादेखिको सुनिराख होला. The third law of motion says that every action has an equal and opposite reaction. Okay, the mathematical representation of Newton's third law of motion can be, okay, suppose let us think that let A be a body exerting a force of F. Okay, F and the mathematical vector symbol, okay, which means that force is a vector quantity. Let A be a body exerting a force of F on a body B. There are two bodies A and B, you know, and body A is exerting a force on body B. Then body B too will exert a force of minus F on body A, which gives us as force which is on A due to B will be equal to minus of force which is on B due to A. बुझ्यौ? So this is actually saying that every action has an equal and opposite reaction. Okay, so according to the third law of motion, in every interaction, there is a pair of forces acting on the interacting object. Okay, so if there are two bodies which are interacting, or two bodies or two objects, what will happen is during that interaction, there is always two pair. There is always a pair of forces. Okay, and they are called as action-reaction pair. And the magnitude of the forces, the two forces, action and reaction both, the magnitude of the forces are equal, and the direction of the forces is opposite to each other. Okay, so the direction of the force of the first one will be opposite to the direction of the second force. All right, so that is all that you need to know about Newton's third law of motion. Okay, so in your class 9th standard, okay, you are just introduced to this three laws of motion by Newton. Okay, you will understand it more properly, and then like in a deep way, okay, in your higher classes. But right now you just need to understand what is the law, okay, the statement of the law, and then what does it actually mean to say. So त्यति कुरा मात्रै तिमीहरूले बुझ्यो भने भइहाल्छ. Okay, and there are some numericals and all which are related to it, which we'll be discussing later. All right, so with this we have seen what is Newton's first law of motion, what is Newton's second law of motion, and also what is Newton's third law of motion. Okay, now let us discuss about some different kinds of forces. Okay, the first one is a pull force. Okay, what is a pull force? It is defined as a force that causes an object to move towards a person who is pulling the object. Okay, यहाँ यो कार्टुन पनि देखिरहेको छ तिमीहरूले हैन, he is pulling a rope, एउटा दोरी तान्दैछ. Okay, so तान्ने खालको मुभमेन्टलाई चाहिँ के भन्छ? It's a kind of a pull force. Okay, यस्तोमा चाहिँ के हुन्छ भने चाहिँ it is defined as a kind of a force that causes an object to move towards the person who is pulling it. हैन, केही चिज तिमीले तान्दैछ भने त त्यो अब्जेक्ट तिमीहरूकै साइडपट्टि सर्छ नि त. So that is what it's saying. Some examples of pull forces are, अब दोरी मात्रै तान्नु होइन हैन, some example of pull forces are opening a door, pulling the curtains of a window. Pulling a curtains of a window भनेको चाहिँ खिड्कीको पर्दा क्या खोल्नु बन्द गर्नु गर्छ नि, यसरी तान्छ नि. So pulling the curtains of the window and pulling a rope attached to some object, यसरी नै, and etc. Okay, some more. So talking about different types of forces, the first one is pull force, and it is defined as the force that causes an object to move towards the person who is pulling the object. Next is obviously push force. And now we have talked about pull, now let's talk about the push force. It is defined as the force that causes an object to move from its state of rest. Okay, here our object is at rest. So what will happen? It is defined as a force that causes an object to move from its state of rest. Okay, when an object is pushed, it tends to move away from the person. Okay, whenever an object is being pushed, what will happen? It tends to move away from the person who is pushing the object. एउटा कुनै चिजलाई तिमीहरूले ठेल्दैछ भने त तिमीहरूको त अझै टाढो जान्छ नि त हैन. So it tends to move away from the person who is pushing it. So this cartoon actually displays that he's pushing some kind of a box there. Example say kicking of a ball, you are kicking a ball from the ground, and then pushing a trolley, and then inserting a plug into a socket. अब तिमीले चार्जरहरु गर्दाखेरि, फोन चार्जहरु गर्दाखेरि सकेटमा हाल्छ नि, त्यहाँ पनि तिमीले there is a push movement you are doing it. You are pushing the plug into the socket and also putting the तिमीले केबलहरु पनि फोनमा हाल्दाखेरि you are pushing the cable inside your phone हैन. So all these kinds of movements are known as push forces. Talking about the next kind of force, it is attraction and repulsion force. Okay, so repulsion is a force between two similar or like charges, while attraction is a force between two dissimilar or unlike charges. So this is something which we have studied in the lower classes as well. We have already understood that whenever there are like charges, same खालको चार्ज छ भने, same खालको चीज छ भने, they repel each other, and whenever there is opposites attract. है ना? So example say attraction between two unlike charges, positive negative, है ना? Positive and negative charge से के हुन्छ, they attract each other. Whereas repulsion between like charges, positive charge or negative charge छ भने चाहिँ they repel each other. Similar is the case with magnets. Magnet को north pole र south pole हुन्छ नि. There are two poles in a magnet, you know, north pole, south pole. So what will happen? This is the case of attraction. Whenever there is different poles which are kept towards facing each other, होइन, त्यति बेला चाहिँ attract गर्छ. Repulsion चाहिँ कहिले हुन्छ? जब same pole चाहिँ हामीले same poles of magnet are brought close to each other, it will repel each other. South south, north north play भने it will repel. But whereas if you keep north and south together, it will attract. Same thing. यहाँ attract र repulsion they same देखाउँछ. Alright. So this attraction and repulsion we see most in the charges and in case of magnetism. So that is why this examples are there. Alright. So the next kind of force again is a tension force. Okay. Now tension force is, what is a tension force? It is defined as a force that is transmitted through a rope, okay, or a string or a wire when pulled by forces acting from the opposite sides. Okay, the tension force is directed over the length of the wire. Okay, so अब यहाँ एउटा दोरी छ अरे, दुईजना मान्छेले तान्दैछ अरे, हैन? So what is happening? Tension force चाहिँ एउटा string को, it is acting on the opposite sides. Okay, it is are transmitted through the rope. A tension force is transmitted through the rope or a string or a wire when pulled by forces acting on opposite sides. Okay, so tension force it is directed over the length of the wire. अब यो खाली यस्तोमा मात्रै हुँदैन हैन, दुईपट्टिबाट फोर्स केही चिजले तान्दैछ र यहाँनिर दोरी तान्यो भने मात्रै टेन्सन हुँदैन. नेक्स्ट काइन्ड अफ फोर्स कुड बी, टेन्सन चाहिँ कसरी हुन्छ भने चाहिँ एउटा भित्ताबाट तिमीले एउटा यस्तो दोरी झुन्डाइराख्छ अरे, अनि त्यो दोरीमा चाहिँ you have hung a some object, हैन, माथिबाट दोरीबाट झुन्डाइकिन केही चिज झुन्डाइराख्छ अरे तिमीले, त्यसमा पनि त्यो दोरीमा there is some kind of tension which is being applied. Okay, so there is some kind of tension force. The fifth force that we are going to talk about today is the normal reaction force. Alright, so normal reaction force के हो भने it is the force exerted by an object, okay, to counteract the weight or the force exerted by other object in contact with it. Therefore, its magnitude will be same as that of the force exerted, and it will be perpendicular to the surface of contact to the two bodies. Okay, so normal reaction it will act perpendicular to the surface which is in contact with the two bodies. All right. So कसरी भन्दाखेरि चाहिँ, suppose you take this as a surface, on top of that there is this block. अब यो ब्लकमा हुँदाखेरि चाहिँ यो ब्लकले, this object is putting some weight force down, हैन, there is a contact between the table and the block here. अब यो ब्लकले चाहिँ एउटा वेट फोर्स एक्ट गर्दैछ तलपट्टि. यो जब वेट फोर्स यसरी एक्ट गर्दैछ त्यति बेला चाहिँ टेबलको सर्फेसले चाहिँ there is a normal reaction force which is being applied. Okay, त्यो चाहिँ इक्वल एन्ड अपोजिट हुन्छ. यो जुन चाहिँ वेट फोर्स छ त्यसकै अपोजिटमा चाहिँ त्यति नै फोर्स चाहिँ एक्ट गर्छ नर्मल रियाक्सन. अब सिमिलरली अब यो एउटा स्ट्रेट उयसमा नभएर एउटा इन्क्लाइन्ड पाथमा छ अरे, हैन, इन्क्लाइन्ड प्लेनमा छ अरे, यस्तो अलिक अल्गोमा छ अरे ठाउँ. यस्तो ठाउँमा छ भने वेट फोर्स त डाउन नै एक्ट गरिरहेको हुन्छ, बट रियाक्सन फोर्स जहिले पनि सर्फेसको परपेन्डिकुलर हुन्छ नि त. ओके, सो नर्मल रियाक्सन फोर्स इज अलवेज परपेन्डिकुलर टु द सर्फेस. सो यो सर्फेस भयो, यो कन्ट्याक्टमा छ, यसको परपेन्डिकुलर चाहिँ नर्मल रियाक्सन फोर्स एक्ट गरिरहेको हुन्छ. सिमिलरली थर्ड इक्जाम्पल इज अ बिट कम्प्लिकेटेड. यसमा चाहिँ के भनेको हुन्छ, अ बल फलिङ फ्रम अ सिलिन्ड्रिकल अब्जेक्ट. अब एउटा सिलिन्ड्रिकल अब्जेक्ट छ अरे, यसको सर्फेसमा चाहिँ हामीले एउटा केही चिज राखेको छ अरे, त्यो झर्यो भने कस्तो हुन्छ, वेट फोर्स डाउन एक्ट गरिरहेको हुन्छ, बट सिन्स द बडी इज इन कन्ट्याक्ट विथ द अब्जेक्ट हियर, हैन, जहाँनिर कन्ट्याक्ट छ त्यसकै अपोजिटमा चाहिँ normal reaction force act गर्छ त्यसरी. Okay, so normal reaction force चाहिँ के रे, actually it is the force exerted by an object to counteract the weight force, okay, exerted by the other object in contact with it. So therefore its magnitude will be same as that of the force exerted, and it will be perpendicular to the surface in contact to the two bodies. बुझिहाल्यो हैन. म्याग्निट्युड चाहिँ त्यही भनेको मैले इट विल बी इक्वल भन्दाखेरि चाहिँ वेट फोर्स जति एक्ट हुँदैछ नर्मल रियाक्सन फोर्स पनि त्यति नै एक्ट हुन्छ। अब यो ब्लकको हिसाबमा भन्ने थिएँ नर्मल इक्जाम्पल दिन हो भने चाहिँ एउटा टेबलमा त्यो किताब राखिराख्छ अरे होइन त्यो किताबले देयर इज द वेट अफ द बुक विल गिभ सम काइन्ड अफ फोर्स टु द टेबल एन्ड द सर्फेस अफ द टेबल विल एक्सर्ट अ काइन्ड अफ normal reaction force, okay, which is equal and opposite. All right, so these are all that you need to know about normal reaction force. The sixth force we study today is the friction force. All right, so friction force it refers to the force generated by two surfaces that contacts and slides against each other. These forces are mainly affected by the surface texture. Okay, so friction forces कहिले हुन्छ भन्दाखेरि चाहिँ it refers to the force that is generated by two surfaces. So जहिले पनि यो friction force हुँदाखेरि चाहिँ we are considering two surfaces which are in contact with each other. Okay. So generally there are four types of friction forces: static friction, sliding friction, rolling friction, and fluid friction. Okay. And the examples of frictional forces could be walking or running, यसमा पनि फ्रिक्सन हुन सक्छ, राइटिङमा, स्केटिङ, लाइटिङ अ म्याचस्टिक एसेट्रा. ओके, अब यहाँनिर देयर इज अ स्केट बोर्ड होइन, स्केट बोर्ड चाहिँ कसरी मुभमेन्ट त अगाडि हुन्छ नि त, सो द फोर्स एन्ड एक्सेलरेसन इज इन द सेम डिरेक्सन, फोर्स चाहिँ अगाडिपट्टि मुभ हुँदैछ फोर्स, बट तिमीहरूले के गर्दैछ खुट्टाले यसरी यहाँनिर भुइँमा टेकेर यसरी गर्छ नि, खुट्टामा स्केट बोर्डमा एउटा खुट्टा हुन्छ अर्को खुट्टा भुइँमा हुन्छ, त्यो यसरी टक्क पुश ब्याक गर्दाखेरि त्यो स्केट बोर्ड अगाडि जान्छ नि त होइन एउटा खुट्टाले, सो त्यति बेला चाहिँ फोर्स यसरी एक्ट गरिरहेको हुन्छ, फ्रिक्सन यसरी एक्ट गरिरहेको हुन्छ. नेक्स्ट राइटिङमा चाहिँ कसरी भन्दाखेरि चाहिँ जहिले पनि तिमीहरूले फ्रिक्सन एनेबल्स अस टु रिड राइट एन्ड ड्र अन द पेपर होइन, एउटा पेन हुन्छ, पेनको टिपमा पनि देयर इज वान सर्फेस एन्ड द पेपर जुन चाहिँ भुइँमा तिमीहरूले पेन्सिलको या त पेन्सिलले बनाउँदै गर्दा पेपरमा या त पेनले लेख्दै गर्दा पेपरमा जुन चाहिँ हुन्छ पेपरको सर्फेस इज वान सर्फेस एन्ड द टिप अफ द पेन्सिल अर द pen is another surface. So whenever those two are touching each other and whenever you're writing something or drawing something, there also friction takes place. Okay. Third, lighting a matchstick. अब मचिसको टुप्पो र त्यो मचिसको जुन चाहिँ त्यो बाल्ने हुन्छ नि क्या म्याचस्टिकको हो, त्यो यस्तो गर्दाखेरि स्ट्राइक गर्दाखेरि चाहिँ देयर इज अल्सो फ्रिक्सन द्याट इज ह्यापनिङ देयर. एन्ड द थर्ड इज वाइल वकिङ. ओके, हिँड्दै गर्दाखेरि walking force is in the front direction, but whereas friction will also be always be in the opposite to the force which is being applied. Okay, so these are all that you need to understand, and then in the next class what we are going to do is we are going to study about the we are going to actually solve some of the numericals, okay, and also do some questions. All right, so that will make you understand this topic little bit more. Okay, so thank you so much for listening to the class. I hope you understand and then it is useful for you. Okay, so if you liked it, leave a like, and also if you didn't understand something, leave a comment. I'll try to answer those. All right.